Hi friends, my name is Dattaraj Rao. I'm the author of the upcoming book, Keras to Kubernetes, Journey of a Machine Learning Model to Production. Today I want to talk about a couple of upcoming and advanced topics in deep learning. One is neural style transfer and second is generative networks. Style transfer basically means you're taking an existing image or like a painting, say Starry Nights from Vincent van Gogh, and applying the style of that painting to a different image. Now, let's say I have an image like my photo, and I want to apply, I want to make it look like a painting. So one of the ways of doing it is I can take an image of a painting and superimpose that image on my image, something like this. Now, this is pure computer vision. There is no learning involved here. All I'm doing is taking one image, mixing it with the other image, and kind of doing like a superimposition of pixels. So this works, but this doesn't really give you that artistic feel. The other way of doing this is what is neural style transfer. The beauty of deep learning neural networks is that as they train on image data, the different layers capture different patterns inside the images. Like maybe the earlier layers are capturing different patterns of edges, the further down layers are capturing contours, and then further down the layers are capturing full-fledged objects and shapes in the image. So basically, when you train on multiple of images, especially images of paintings, you can capture like the style in which these images are formed, and then you can apply that to a different image and then make it look as if that image has been drawn as per the original style, something like this. So I took a picture of myself and applied using Starry Night's style, and it looks something nice. So it gets that artistic feel. I talk about how to do this and like an example in my book specifically on neural style transfer. Next, let's talk about generative networks. These are neural networks that learn from data and can generate new data, maybe image data or text data. So they learn and become good enough to start building new data sets. So one of the examples I took was text data. So I took a data set of movie names. So from IMDb website, there is a publicly available data set which has like 5,000 movies with different characteristics. For this example, I specifically just took like the movie names. So 5,000 movie names. I trained a neural network. In this case, text is handled like a sequence of characters or words. So in this case, we use a different neural network called recurrent neural network. So this is different from the traditional feed-forward neural networks where this neural network has layers that point back to itself and kind of store memory information as it learns. So it can kind of store context information as we learn sentences, etc. So this particular example, I took movie names, trained a neural network, and then used that network to start predicting new movie names. So after about 500 epochs of training, this network started giving out some random movie names, which are, I mean, they're definitely not true movies, but what it thought that maybe these could be names of movies which look like names of movies. I mean, things like Gun Street Hope, Men, Monsters, Secrets. I mean, these definitely are not Hollywood movies. But then the point is it learned patterns of movie names and started generating new sentences which could be corresponding to movie names. So this is kind of an example of generative networks. This particular example, I have this kernel deployed on Kaggle kernels and this notebook, and I'm going to make this available as part of this YouTube video. So you can just see the entire code for generating these movie names as part of the Kaggle as a Kaggle notebook, and try it out yourself. Maybe you have a different data set you want to try this on to see how generative network works. So feel free to reuse this code. So in my book, I talk about these kind of examples, style transfer, generative networks. First half of my book, I cover more deep learning, basic concepts of machine learning, deep learning, and the focus is more from a data scientist. The second part of the book, we take the data science hat off and put the software developer and DevOps hat on. And then we talk about how to build models and deploy models to production, kind of containerize models, deploy them as on a Kubernetes cluster and make them available on a production at production level and deploy them as microservices. So I hope you get a chance to read my book and like it. Do let me know your feedback. Thank you.